This experiment requires the handling and the production of highly toxic materials, so a lot of care must be taken. The reaction and the combustion must only take place in a fume hood or outdoors due to the production of many toxic gases. This reaction must only be carried out if you have the ability to dispose of waste materials like mercury appropriately. Do not even think of doing this experiment if you plan to dispose of the chemicals down the drain or in the garbage. Mercury is extremely toxic, and even just small amounts can be detrimental to wildlife. Mercury thiocyanate was discovered in 1821 in Germany. Soon after its discovery, it became a publicly available firework in Germany known as the Pharaoh's Serpent. However, it was eventually banned due to its highly toxic nature. The compound itself is a highly toxic mercury salt, and the combustion simply produces more toxic compounds. During the experiment, be sure to avoid as much contact as possible with any of the compounds. For this reaction, you will need about 4 grams of potassium thiocyanate, 0.3 milliliters of elemental mercury, and about 15 milliliters of concentrated nitric acid. The nitric acid must absolutely be concentrated, so a minimum of about 65% nitric acid is required. First, about 15 milliliters of concentrated nitric acid was prepared. It doesn't have to be exact, as the nitric acid is already in significant excess. The nitric acid was then transferred to a beaker. About 0.3 milliliters or 300 microliters of mercury was measured using a syringe and added to the nitric acid. Immediately after the addition of the mercury, the solution starts to turn green and bubble. Dark red nitrogen fumes are released from the solution, and the solution begins to get darker and darker. The mercury reacts with the nitric acid in the reaction shown above. The water-insoluble elemental mercury reacts to form the water-soluble mercury nitrate. It is extremely important to note that the mercury nitrate that we require for this reaction is mercury 2 nitrate. Mercury 2 nitrate will only form in concentrated nitric acid solution. If elemental mercury is reacted with dilute nitric acid, instead it forms mercury 1 nitrate. The major nitrogen gas evolved in this reaction is nitrogen dioxide. Nitrogen dioxide is quite toxic, and for this reason it is extremely important to do this reaction in a fume hood or outside. The reaction is complete when there's no visible elemental mercury left. You will also know the reaction is complete when the amount of nitrogen dioxide gas released is significantly decreased. At this point, it appears that no nitrogen dioxide gas is released, but when I swirl it, a significant amount of nitrogen dioxide is released. We are going to need to boil the solution to get out as much of the gas as possible. This boiling step is extremely important and has a twofold purpose. Firstly, it serves to clear up the solution by releasing any excess nitrogen dioxide gas. This is because at higher temperatures the solubility of nitrogen dioxide in water decreases. Secondly, although we use concentrated nitric acid, there is still a little bit of mercury 1 nitrate that is produced. The mercury 1 nitrate product is undesirable, but luckily, by boiling it we can convert it to mercury 2 nitrate. Upon boiling or exposure to UV light, mercury 1 nitrate disproportionates into elemental mercury and mercury 2 nitrate. The mercury 2 nitrate dissolves into solution, and the elemental mercury reacts with the concentrated high temperature nitric acid to again form mercury 2 nitrate. The solution is boiled until red gas is no longer released and instead white gas is released. You can also see that the solution clears from a dirty green color to a fairly light yellow color. This signifies that the majority of the nitrogen dioxide gas has been released from the solution. At this point, you should remove the solution from heat and let it cool to room temperature. The solution should clear up, and once it's at room temperature, it should appear to be crystal clear. This is what the solution looks like after about 10 or 15 minutes. Next, transfer the nitric acid mercury 2 nitrate solution to about 40 to 45 milliliters of water. Then rinse your solution flask with about 40 milliliters of water. You can optionally rinse it twice with 20 milliliters of water, which is actually probably a better idea. Next, add about 4 grams of potassium thiocyanate. Simply roughly weigh out 4 grams and dissolve in as much water as needed. The amount of potassium thiocyanate added is in slight excess to assure that all of the mercury 2 nitrate is consumed. Mercury thiocyanate is extremely insoluble in water and will precipitate out. Any excess potassium thiocyanate will remain in solution. Stir the solution a bit and then let it settle. The mercury thiocyanate is considerably more dense than water. The mercury thiocyanate will sink rather quickly. This should take about 10 minutes at most. Next, decant the liquid into another beaker. Be careful not to let any of the mercury thiocyanate fall in with the water. Transfer this opaque mercury-ridden solution to an appropriate waste container. Do not pour it down the drain. In order to avoid dirtying more glassware with mercury salt, I opted to transfer the mercury thiocyanate to a filter paper with some paper towel underneath. To get as much mercury thiocyanate out of the beaker, I rinsed it a few times with water. I had to change the paper towel a few times, and each time the soggy, mercury-contaminated paper towel was placed in an appropriate mercury waste container. Let the mercury thiocyanate dry, changing the paper towel as needed. After about 10 or 15 minutes, the mercury thiocyanate should have dried up enough to become a paste. You can test the consistency of the mercury thiocyanate using something like a spatula. Once the mercury thiocyanate has become a paste, you can use something like a spatula to shape it. You should absolutely not try to shape the salt using your fingers, even if you are wearing gloves. I decided just to shape the salt into 2 small little mounds. After the mercury thiocyanate has been shaped, you can just leave it to dry. You don't need to pack it or compress it to make it more dense. I changed the paper towel again, and I let the mercury thiocyanate dry overnight. By the next day, they were completely dry and solidified. The next day, I tested the product. Due to the small amount of salt, the results were entertaining but not spectacular. The result of burning both looked very similar, so I'll only include the video of one. I decided to redo the experiment using 2 milliliters of elemental mercury instead. The results were more entertaining, but the cleanup was much more difficult. I was able to make about 3 mounds of mercury thiocyanate, each one weighing a little over 10 grams. In this first take, I only ignited one of the 10-gram mounds. In the next take, I put 2 of the mounds side by side and ignited them simultaneously. Igniting the mercury thiocyanate causes it to decompose according to the reaction shown above. The reaction produces mercury 2 sulfide, carbon disulfide, and carbon nitride. The mercury 2 sulfide that is produced readily reacts with oxygen to produce elemental mercury and sulfur dioxide gas. Carbon disulfide is extremely flammable, so the moment it is produced, it reacts with oxygen to produce CO2 gas and SO2 gas. Finally, the carbon nitride is what the snake is primarily made of. Some of the heat of the reaction will decompose the carbon nitride into dicyan gas and nitrogen gas. The nitrogen gas is inert, but the dicyan gas is highly toxic. It is extremely toxic because it can be readily reduced to form cyanide. I've included here all of the combustion products that are produced. Some mercury salt might also still remain. This is the ignition of 2 piles, with a total weight of a little over 20 grams. Out of all of the reactions that I have done with the mercury thiocyanate, this one was the best one. This is just a demonstration to show how fragile and brittle the resulting ash is. The snake is made up of almost entirely carbon nitride. The carbon nitride is quite spongy and it contains a lot of the gases produced in the reaction inside of it. So when the snake is broken apart to clean it up, you must also be aware that gases will be released when you break the snake apart. The snake is highly contaminated with mercury, so clean up any piece that you can find and place all of the bits in an appropriate mercury waste container.